All right, Honors Algebra 2, here's a little instructional video over what we accomplished today in class on Wednesday, January 6th for Honors Algebra 2, bonus for, oh, this is for Honors Algebra 2. All right, so on this page, this is page 3 in your 4-4 to 4-6 game plan. What we're going to do here is simplify all of these rational functions involving I. Okay, so we've got fractions, rational function. To get rid of an I or a root in the denominator, you want to multiply the top and the bottom, numerator and denominator, by the conjugate of the bottom, the conjugate of the denominator. The conjugate is the same two terms, 3 and 2i, with the opposite sign in between, plus and plus. Okay, so we're going to multiply the top and bottom by 3 plus 2i. And when we do that, up top, we're going to get a 12 plus 8i. When you multiply with conjugates, you only have to do the first and last part of FOIL. That is what we saw on number 23 and 26 on page 2. Okay, so I just have to do 3 times 3, and then negative 2i times 2i is a negative 4i squared. Remember, if I is the square root of negative 1, then I squared is a negative 1. So negative 4i squared would become negative 4 times negative 1, which is a positive 4. So we're going to have 12 plus 8i divided by 13. So on number 2, if I have 3i is like 0 plus 3i, so the conjugate is 0 minus 3i. So 0 minus 3i is a negative 3i. I'm going to multiply the top and bottom by a negative 3i. So up top, that's just simply a negative 15i. Down below, that is a negative 9i squared. I squared is a negative 1. Negative 9 times negative 1. Gives you 9 in the denominator. Divide both top and bottom by 3. All right, number 3 here. I got 5i in the denominator. The conjugate would be a negative 5i. Multiply the top and bottom by negative 5i. Down below, 5i times a negative 5i is a negative 25i squared, which is a negative 25 times a negative 1. That gives me 25. Up above, I'm going to have a negative 15i plus 10i squared. I squared is a negative 1. 10 times a negative 1 is a negative 10. I'm going to rewrite this, and I'm going to put the real part first. So negative 10 minus 15i. Then I'm going to divide everything by 5. All right, on number 4, negative 4i over 2 minus 3i. I'm going to multiply everything by 2, the top and bottom, that is, by 2 plus 3i. That is the conjugate of the denominator. Up top, I'll have a negative 8i minus 12i squared. Down below, the first and the outer part of FOIL, I'm going to have 4 minus 9i squared. I squared is a negative 1. So negative 9 times a negative 1 is a positive 9. Negative 12i squared is going to be a positive 12. I'm going to have negative 8i there. I'm just going to switch the order. 12 minus 8i, and then over 13. Number 5. 3 plus I over 2, or 1 minus 2i. I'm going to multiply top and bottom by 1 plus 2i. So down below, I'm going to have 1 minus 4i squared, just the first and the last part of FOIL. Up top, I have to do all of FOIL because these aren't conjugates. So 3 plus 6i plus a single i plus 2i squared. All right. 2i squared is a negative 2, so 3 minus 2. 6i and 1i is 7i. 3 minus 2 is 1 plus 7i over 5. That is page 3. That's what we did today in class. Then we took it over to page 14 next. All right. Now, something like 17 here, so the top of page 14. These are conjugates, 5 minus 6i, 5 plus 6i. So if you see you have conjugates, you just have to do the first, 5 times 5, and the last part of FOIL, negative 6i times 6i. A negative 36 times a negative 1 is a positive 36. You get an answer of 61. The 30i and the negative 30i would cancel. I'm going to write this as 2 plus 3i twice. I'm going to do the first, 4 plus 6i plus 6i plus 9i squared. All right, let's write the real part first. A negative 5 plus 12i. 19 is one we did today as well. 2 plus 6i over 5i. The conjugate would be a negative 5i. I'm going to multiply the top and bottom by a negative 5i. All right. Negative 10i minus 30i squared divided by negative 25i squared. I squared is a negative 1, so that negative 30i squared is going to become a positive 30, and that negative 25i squared is going to become a 25. I'm going to rewrite the 30 first, minus 10i divided by 25, divide everything by 5. There we go. On 20, I'm going to multiply the top and bottom by 1 plus 3i. I guess it's going to give me 8 plus 24i. Down below, I'm going to have a 1 minus 3i, or 9i squared. Minus 9i squared is going to become a positive 9. 1 plus 9 is 10. I have 8 plus 24i over 10. I'm going to divide everything by 2. And finally, it was page 15 that we talked about. These would be more bonus type questions. On your upcoming test, numbers 3 through 6, you can write free points there. I'll remind you there in class. So solve each inequality. So this is like saying it's similar to x squared minus x minus 20 equals 0. That can factor what multiplies to 20 and differs by 1. X minus 5x plus 4 equals 0. That has two x-intercepts of 5 and negative 4. This is a parabola. It makes the u because it's a positive x squared. It has one x-intercept, crosses the x-axis when x is negative 4, and when x is 5, it has a y-intercept of negative 20, which would be further down here. But here's the generic graph. It makes a u. Make sure you see that it crosses the x-axis at negative 4 and then at 5. This question is asking you, when is this curve less than 0, i.e. when is this curve below the x-axis? Because this is your y value. If y is 0, you're at the x-axis, so when is it below the x-axis? Well, this curve is below the x-axis between the values of x equals negative 4 and 5. So between x equals negative 4 and 5, we put parentheses because it does not include either negative 4, nor does it include 5 because there's no equality part there. All right, number 8, x squared plus 2x minus 48 greater than or equal to 0. We're going to treat that as x squared plus 2x minus 48 equals 0. What multiplies to 48 differs by 2, positive 8, negative 6. So x equals negative 8, x equals positive 6. Or your x-intercepts, negative 8 right there, positive 6 right there, negative 48, which would be way down there, is your y-intercept. Again, this makes a u. It's a positive x squared, so make a curve through those points there. So when is this curve greater than or equal to 0? That means when is this curve at or above the x-axis? So it has a y value of 0 or more at or above the x-axis. The curve is above the x-axis here and here. So we've got an interesting situation. So it's going slowly all the way to the left for x, which is a negative infinity for x, always a parenthesis around negative infinity or positive infinity, to negative 8. Negative 8 is where it's at the x-axis. We use a bracket there because greater than or equal to, you are allowed to be equal to 0 in this one. Union, it picks back up being at the x-axis at 6, another bracket because I'm allowed to be on the x-axis, greater than or equal to 0, all the way to infinity. This graph is going to keep going to the right and going up. Again, a parenthesis around infinity. Again, this is just stuff to know for pre-calculus and calculus. Could be a bonus on the upcoming test. This is Yak Math Videos signing out.